So now what I'm going to discuss is gases. As you can see with gases, the particles are far apart from each other. And because they are very far apart of each other, they occupy a big volume. So they are really far apart. So this volume is absolutely massive. Now, if you remember before, I said density is mass divided by volume. If you increase the volume, what ends up happening is the density begins to drop. So the density of solid is high, the density of liquids is high, but when you compare it to the density of gases, it's extremely low density gases. And because they're very far apart from each other, it is compressible. Liquids are not compressible, solids are not compressible because the particles are touching each other. There's very minimal space between the particles, whereas with a gas, they are far apart, so you could actually compress it. And another thing is you could actually change the shape of the gas. So the gas can occupy different shapes. So if you put it into that container, the gas will spread out in that container. If you put the gas in a smaller container, it will spread out in that container. Obviously, if you put it in a smaller container, the pressure is going to be higher. I'm not going to go into too much detail about pressure, but pressure is about the number of collisions per unit of area, the kinetic energy, blah, blah, blah. But the pressure is basically hitting the sides. So if you're making it smaller, the volume, the pressure builds up. So the shape of a gas can change depending on its container. And they move randomly in all different directions. We call this Brownian motion. So as they're moving about, they're colliding with each other. They're also colliding with the size of the container, which generates pressure. So pressure is colliding with the sides of the container. Pressure isn't then colliding with each other, just the sides of a container. Now, there's a relationship between temperature and kinetic energy, so the movement energy. As the temperature increases, the movement energy increases, the kinetic energy increases. Now, not all the particles have the same kinetic energy. Some are moving slightly faster than others, but there's an average kinetic energy. And this is known as your temperature. So your temperature, when we talk about temperature, that tells us the average kinetic energy. That is basically some particles might have a higher temperature because they have a higher kinetic energy than other particles. But temperature just tells me the average temperature, but every single particle has a slightly different kinetic energy. So gases have no definite shape. Liquids cannot be compressed, solids cannot be compressed, but gases can be compressed. And they can also expand to fill up an empty space. And you could also compress them.